Welcome to another video on Edexcel for the maths, and we're talking about the Core Pure book 1, Core Pure Mathematics book 1, year 12, and this is chapter 2, Argan Diagrams and Complex Numbers. We're going to talk about how complex numbers can be represented in Argan diagrams. You're going to learn about modulus and argument form of complex number, and then we're going to represent some loci with the regions on the complex numbers. Okay, so we'll go through this whole unit in this chapter today. Okay, so the Argan diagram is nothing but a pair of axes like we normally have in our coordinate system. Okay, but only difference is in this pair of axes we don't have x and y there. We call it real axis for the x-axis and imaginary axis for the y-axis. And what do we represent on this Argan diagram? Like we normally represent the points is the complex number. Okay, so like normal coordinates, guys, what we have to do is we have to represent the real number, real part of the complex number into the real axis, and so on and so forth. So these are the four complex numbers. You can draw the axis yourself, just 3 and 4. That is a 3 and this is a 4, so that would be point A. Okay, you can represent all these four complex numbers on this Argan diagram. So nothing changes. So like A is here, B is here, like in 4 different quadrants we plotted the 4 complex numbers in Argan diagram. So this part is straightforward. Okay, the first type of questions you're going to get is they will ask you to find an answer to a complex number calculation, which you've learned in the previous videos, and represent the answer on the Argan diagram. This is fairly straightforward. Right, so this is the first exercise 2A. All the questions are show these on Argan diagram. So everything you expect to do some calculations, multiplication, addition, subtraction, you all learned in the previous videos. Show them in the Argan diagram. And the next one is, guys, finding the modulus and argument. I'm going to do that with you now. So let's first define what do we understand by modulus and argument of a complex number. This complex number A is actually 3 on the real axis and 4 on the imaginary axis. Okay, if I have to find the modulus of this complex number A is the distance of this point from this origin, which is fairly, you can relate this to the normal number system. That's a 3, that's a 4. So modulus of A would be 3 squared plus 4 squared square root is 5. And the argument is the angle that line makes with the positive real axis in anti-clockwise direction or in clockwise direction. We'll talk about that a little later. So the argument here in this case would be argument of A would be tan inverse of 4 over 3. Okay, this is an exam style question, guys. They will ask you to find modulus and argument of certain complex numbers given into form of A plus BI. And I'm going to do a question to give you an example of that. Okay, so we're going to go over question number 10 on exercise 2B of the book. It says this is the complex number. They've asked you to find the modulus of this. Then they've asked you to find the modulus of z over z complement. We're going to first work out what the complex number is. Then they have to find the argument of all of this in terms of pi. Okay, so we're going to show you this question now. So that's complex number, guys. Step 1 to find the modulus. Okay, we just do minus 1 squared plus minus root 3 squared square root, and the answer is 1 plus 3, and the answer is 2. So modulus of z is equal to 2. To find the argument of z for this part, I'm expecting you to first of all, very, very important, draw this on the Argan diagram. So this will be minus 1 and minus root 3. This is minus 1 and that's minus root 3, guys. Now this is where I'm going to explain to you again. If you start in clockwise direction, the angle from positive real axis would be this bit. Okay, but the principal argument is always argument of any z, any complex number, is generally between minus pi and pi. That means you're allowed to go in the anti-clockwise direction only up to pi. Then if you don't get the complex number in that form, you're allowed to go from here to here. So in this particular case, guys, we'll be looking for this angle, then take that away from 180 degrees of pi, then write the final answer. Okay, so let's work out this angle, people. This will be tan inverse of root 3 over 1, which gives me, if I remember correctly, obviously you can use a calculator, that is 60 degrees, or pi by 3. Right, so the argument of z will be negative of pi take away pi by 3. Can you see? It's not a full pi, it's less than, it's pi by 3 less than that. That gives me, this is 2 pi over 3, and this is minus 2 pi over 3. This is the argument of z. I would now expect you to work out this complex number, okay, then find its modulus, then find its arguments, please. Let's try. I'll give you a couple of minutes to work this out. Right, so I'm sure you worked it out. The modulus of z would be minus 1 plus iota root 3. When you divide z by z complement, okay, so you're going to be doing what? Multiplying and dividing by the complement of z complement. Okay, you'll end up getting this. If you have got this, guys, we're going to be working out the modulus and the argument of this number now, please. Okay, give yourself time. Right, the argument part, modulus of this function complex number comes out as 1. For the argument, what I said to you, it's always advisable to draw this number, this complex number, into the complex Argan diagram. This is negative half and plus root 3 over 2. It's somewhere over here. Right, guys, this is negative half and this is root 3 over 2. So argument of this will be a positive argument, this one. So how would you figure that out, people? You find this angle in the middle, then take it away from pi. Do that for me. Let's see if the answer matches with mine. Right, so the angle comes out as pi over 3. I'm looking for the argument from the positive real axis in the anti-clockwise direction because it's less than pi. So the argument of z over z complement comes out as, once again, pi minus pi over 3. It is 2 pi over 3. Okay, if you work out argument of z complement on its own, z conjugate of z, I keep saying complement, is conjugate of z, and that will also be, I think, 2 pi over 3. You can check, because what I know is, guys, a complex number and its argument are generally the reflection in the real axis. Okay, complex number a and its argument d, can you see there? They are the reflection in the real axis. So once again, guys, to finish this particular topic off, you have to draw a complex number into an Argan diagram before you work out the argument. And argument should be, that's generally the principal argument, we call it. It's generally between minus pi and pi. And arguments are always given in form of, in the radians unit. So next we move on to 2.3, third unit, which is modulus argument form of complex number. All we know up till now is only one way of writing complex number, which is x plus iy or a plus ib. But now we're going to be working out a second way of writing complex number, which is really important for geometrical purposes. And I'll teach you how do we write complex number in mod arg form. Okay then, so what is the modulus argument form of a complex number? If a complex number z has a modulus of, let's say, any number r, we call it, and its argument of that z is an angle theta, then we can write the complex number z as, in a mod arg form, r cos theta plus iota sine theta. Guys, be very careful. This has to be cos of something plus iota of sine something. If this is no plus there, we have to do some trigonometric manipulation to bring that plus a. anyway. So express this in the form of r cos theta plus iota sine theta. When I learned my maths, we used to do a shortcut of this. We used to call it r cis theta. Okay, but that's fine. This is up to you. When you come to that stage, you can use shortcut as well. Step one is change this complex number into the form of r cos theta plus iota sine theta. So what do we need to do, guys? We need to find its modulus, which will be r. We need to find its argument, and which will be theta. So that's step one. So do that for me, then we can write this in modulus argument form. Right, so the simple calculation, we work out that modulus is root 29, and for the argument I'll have to first draw it on the Argan diagram. This is the angle theta I'm looking for, okay, and it has to be in the radians, and what my calculator gives me now is this. I've changed unit into radians, times per 5 over theta. My answer is, so it's not giving me exact, so that means we cannot find this exact here. The theta here is, this theta here is 1.190203, okay, but my argument would be pi take away, so argument of z would be pi take away this answer. So I'm going to do that for me here. So this will be pi take away the answer, and it is 1.95 to 2 decimal places. So argument z is 1.95, so to 2 decimal places. So guys, this complex number in the mod arg form would be, this would be minus 2 minus 5 iota, can be written as root 29 cos 1.95 plus iota sine 1.95. If you want to do what I said before, you can just write this as root 29 cis 1.95. Obviously check with the teacher if teachers agree with you using this short notation. Now guys, can you work out this one now for me, please? This is a complex number, remember, even if it doesn't look like it. So this is same as 20 plus 0 iota. Find the modulus and argument for me. So okay, as you can see, argument is 0 degrees because it's on the real axis, and modulus is 20, so this 20 can be written as 20 cis 0. Second type of question, which is the other way around, guys. They've given me a modulus argument form of a complex number. I want to change this back into this, guys. This is fairly simple. You multiply this half with both of them and find the value of a and b. Do that for me, we'll check the answer. Okay, so cos pi over 6 is root 3 over 2. This gives me root 3 over 4 plus iota. Sine pi over 6 is half, 1 over 4. Guys, this is a plus ib form of this complex number. So this is your exercise 2c, changing these into each other's form. Then the next section talks about two very, very important rules. What happens to the modulus and the argument of the complex number when you multiply them and when you divide them? Guys, you got to memorize these rules because they'll be used in some questions later on. So what happens when you multiply the complex numbers? The argument gets multiplied. Multiply the complex number, the modulus get multiplied and the arguments get added. Okay, when you divide the two complex numbers, the modulus get divided and argument gets subtracted. So for the argument part, you can relate them to indices or logs. Okay, but you have to memorize this, guys. So guys, you have to memorize these because we'll be using these into some questions from exercise 2D. We have to do some simplifications using this. Right, guys, I've picked up a question from question number 3 of exercise 2D, and this is the question. This is a complex number 1. Let's call it Z1. This is complex number Z2. They're both written in mod arg form, and we have to write this answer in a plus ib form. First of all, there's a multiplication of two complex numbers. Using these rules, what you need to do is identify the modulus of both the numbers, identify the arguments of both the numbers, then write down the modulus and the argument of the product. and then we change from there. Okay guys, I'll give you some time. Be very careful, there's a catch in the question. I will guys give you a start. The modulus part is straightforward. Modulus of Z1 is 4, modulus of Z2 is half. What is the argument of Z1? What's the argument of Z2? And when if you remember my first few lines when I started modarg form, I did say to you it has to be in the form of cos of the angle plus iota sine. In both of them, unfortunately, we have the negatives. Guys, I'm expecting you now to use your knowledge of trigonometry from the first year, normal maths, to change this into the cis forms cos plus iota. Try it. I will help you with that in a minute. Guys, this is the previous knowledge I was talking about. Cos of a negative angle is cos theta, because cos is an even function, and sine of a negative angle is minus sine theta, because sine is an odd function. Using this, guys, if you have to rewrite this particular Z1 here, okay, and I can write this as cos of negative 5 pi over 9, because negative 5 pi over 9 would stay same as cos of 5 pi over 9 using this, and plus, really important, iota sine and negative 5 pi over 9. What does that give me? Sine of negative 5 pi over 9 will give me minus sine, and that will give me the same thing as this. So guys, with this information, I have changed this complex number into the required form of cis theta. So argument of Z1 comes out as minus 5 pi over 9. Can you similarly work out the argument of Z2 for me, please? So I'm sure you got negative 5 pi over 18 for the argument. Now we're going to work out the complex number Z1, Z2. What happens when you multiply them? The arguments get multiplied, so 4 times half, it is 2, and then we write cos of what happens to the modulus get multiplied. I keep mixing this up, and the arguments are added. So we're going to be doing what, guys? We're going to be doing minus 5 pi over 9 plus minus 5 pi over 9. Both of them, work that out. Let's see what do we get. So okay, I think we get this. You can always check if my calculation I've made a mistake somewhere. Now how do we write this in the form of x plus a plus ib? We multiply this using calculator and write the final answer. So I'll leave that to you guys. Write the final answer in terms of a plus ib. Once again, be very careful using these rules. Find the modulus of z1, z2. Find the argument of z1, z2. But before that, you have to make sure that given complex numbers are in the form which you want, which is cos plus iota sine theta, and you use these two rules to change if it was not given into that form. And the answer comes out as minus 3 minus iota. Guys, I'm going to stop this video here, and we do next video on the loci because it's getting too long. Okay, loci and of the complex numbers on the Argan diagrams. See you soon. Happy learning.